Welcome to this comprehensive guide on C-sharp attributes, designed specifically for beginners. Today, we'll demystify these powerful metadata tags, exploring how they function as descriptive markers within your code, and show you how they can significantly enhance the structure and functionality of your C-sharp applications.
At its core, a C-sharp attribute is a declarative tag or marker that you can apply to various elements within your code, such as classes, methods, properties, fields, and even entire assemblies. These tags act like labels, providing additional information about the code they are attached to without directly changing its operational behavior. These tags provide a sophisticated way to associate metadata, which is essentially information about your code, directly with the code itself. Crucially, this is achieved without altering its executable logic, meaning attributes describe the code rather than dictating its direct actions. Think of attributes as descriptive labels that tell the compiler, the .NET runtime, or other development tools something special and important about the code element they are attached to. For example, they might indicate how a class should be serialized or if a method is no longer supported.
This embedded metadata can then be dynamically queried and processed at runtime using a powerful feature known as reflection. This capability allows for the creation of highly flexible and extensible applications, enabling behaviors to be configured declaratively rather than through explicit code.
Attributes are widely used across the entire .NET ecosystem, playing a fundamental role in many frameworks. For instance, in ASP.NET Core, they are essential for defining routing rules, controlling API behaviors, and even managing authorization policies, streamlining web development. Similarly, Entity Framework utilizes attributes extensively for data mapping between C# objects and database tables, as well as for validation rules. Serialization frameworks, on the other hand, rely on attributes to precisely control how objects are converted to and from various data formats like JSON or XML. Ultimately, attributes help to effectively separate concerns within your codebase, making your applications cleaner, more modular, and significantly easier to maintain. They achieve this by externalizing configuration and behavior details from the core business logic, promoting a more organized architecture. Now that we have a foundational understanding of what attributes are and why they are so valuable, let's dive into some of the most commonly used built-in attributes that C# and the .NET framework provide, starting with the highly practical, obsolete attribute. The obsolete attribute is a vital and indispensable tool for managing the evolution and deprecation of your codebase over time. It's specifically used to clearly mark types or members, such as classes, methods, or properties, that are no longer recommended for use by other developers. When you apply obsolete to a method, property, or class, the C# compiler will intelligently generate a warning message, or even an error, if that marked member is subsequently used in your project. This proactive feedback helps developers identify and update outdated code. This powerful mechanism is incredibly useful for gently guiding developers towards newer, more efficient, or more secure alternatives. It ensures a smooth and controlled transition when you refactor your code, update your libraries, or evolve your public APIs, minimizing breaking changes. You can further customize the obsolete attribute by providing a descriptive message string as a parameter. This message should clearly explain why the member is obsolete and, ideally, suggest a suitable replacement, offering immediate guidance to anyone using your code. Furthermore, for situations where continued use of an obsolete member is unacceptable, you can specify a Boolean parameter to turn the compiler warning into a full-blown compiler error. This effectively forces developers to update their code before it can successfully compile. To illustrate its practical application, here's a quick example demonstrating the obsolete attribute in action. We'll showcase how it can be configured to produce both a compiler warning for soft deprecation and a compiler error for stricter enforcement, guiding developers effectively. Next, let's explore another fundamental built-in attribute, the serializable attribute, which is absolutely crucial for persisting object states and enabling seamless data transfer across different layers or systems within your application. When a class is explicitly marked with serializable, it signals to the .NET runtime that instances of this class are eligible to be converted into a format that can be easily stored, transmitted across networks, and later reconstructed into an identical object, preserving its state. This transformative process, universally known as serialization, is fundamental for a wide array of application functionalities. It's essential for saving application data to files, efficiently sending complex objects across network boundaries, or reliably storing them in various types of databases. Without this crucial attribute, many built-in serialization mechanisms in .NET, such as binary serialization, will simply refuse to process your custom types. This omission will inevitably lead to frustrating runtime errors, as the system won't know how to convert your object into a storable format. Conversely, if you have specific fields within a serializable class that you intentionally do not want to be included in the serialization process, you can explicitly mark them with a non-serialized attribute. This provides fine-grained control over what data gets persisted. This non-serialized attribute is particularly useful for excluding temporary data, sensitive information like passwords, or objects that inherently cannot be serialized, such as active database connections or file handles, from being saved or transmitted, ensuring data integrity and security. To provide a clear understanding, here's a simple demonstration illustrating how to effectively use both the serializable attribute on a class and the non-serialized attribute on specific fields within that class, showcasing their combined utility in managing object persistence. Now that we've thoroughly covered some of the most important built-in attributes provided by the .NET framework, let's transition to an even more exciting and powerful concept: the world of creating your very own custom attributes, tailored to your specific application needs. Custom attributes empower you to define your own unique metadata tags, effectively extending the C# language itself. This allows you to precisely fit the unique requirements and address the domain-specific concerns of your applications, adding declarative power where you need it most. To embark on creating a custom attribute, the foundational step is to define a new class that inherits, either directly or indirectly, from the system, attribute-based class. This inheritance is what designates your class as an attribute and provides its core functionality. By established convention, custom attribute class names typically end with the suffix attribute, for example, my custom attribute. While this suffix is optional when you actually apply the attribute in your code, adhering to this convention greatly improves readability and understanding for other developers. A critical and often overlooked step in defining your custom attribute is controlling precisely where your attribute can be applied. This is achieved by decorating your custom attribute class with the attribute usage attribute itself, which acts as a meta-attribute. The attribute usage attribute allows you to specify whether your custom attribute can be applied to classes, methods, properties, fields, enums, or even a combination of these. This prevents incorrect usage and ensures your attribute is only used in appropriate contexts, maintaining code integrity. To make your custom attributes truly dynamic and adaptable, you can define properties and constructors within your custom attribute class. These allow your attributes to accept parameters, making them highly versatile and configurable to suit various scenarios within your application. These parameters can be passed in two primary ways: as positional arguments, which are supplied through the attributes constructor, or as named arguments, which are set via public properties. This dual approach offers significant flexibility in how you provide information to your custom attributes. Let's walk through a practical example of defining a simple custom attribute that incorporates both positional parameters, passed during instantiation, and named parameters, set through properties. This demonstrates how to build a flexible and informative attribute for your code. Once your custom attribute has been meticulously defined, applying it to your code elements is as straightforward and intuitive as applying any of the built-in attributes we've already discussed. The syntax and placement remain consistent, ensuring ease of use. You simply place the attribute name, optionally omitting the attribute suffix for brevity, enclosed within square brackets directly above the target element you wish to tag. This clear, declarative syntax makes your code's intent immediately obvious. Retrieving the information stored within your custom attributes at runtime is accomplished using reflection, a powerful capability of the .NET framework. Reflection allows you to dynamically inspect metadata about types and members, unlocking the full potential of your attributes. The getCustomAttributes method which is conveniently available on member info objects, serves as your primary and most direct tool for extracting this valuable metadata. It allows you to programmatically access the attribute instances and their associated parameter values.
To bring it all together, here's a comprehensive example demonstrating the entire life cycle, from the initial definition of a custom attribute through its application to a class or method, and finally, the runtime retrieval and processing of its values using reflection.
When designing your own custom attributes, it's crucial to consider their scope and purpose with great care. They should primarily add declarative metadata to your code, rather than embedding complex business logic, which belongs elsewhere in your application. While custom attributes are incredibly powerful, it's important to avoid overusing them. They are best suited for specific, well-defined metadata concerns, not as a general-purpose code extension mechanism, as excessive use can lead to less readable and harder to maintain code. Always document your custom attributes thoroughly using XML documentation comments. This ensures that other developers and your future self clearly understand their intent, proper usage, and the meaning of any parameters they accept, fostering better collaboration and maintainability. It's important to remember that attributes are compiled directly into the assembly's metadata. This means they do add to the overall size of the assembly, and if used excessively or inefficiently, can potentially impact application load times. Use them judiciously for optimal performance. In summary, C# attributes represent a powerful and incredibly versatile feature for adding rich, declarative metadata to your code. They enable elegant declarative programming patterns and significantly enhance the flexibility and configurability of your applications, making them more adaptable. From essential built-in attributes like obsolete, for managing code deprecation, and serializable, for robust data persistence, to the custom creations you can design yourself, attributes provide a robust and extensible mechanism for enhancing and extending your C# applications in countless ways. By truly understanding and effectively utilizing the power of attributes, you can write C# code that is not only cleaner and more maintainable, but also significantly more extensible and adaptable to future changes, leading to more robust and scalable software solutions. Thank you for watching this comprehensive tutorial on C# attributes. We sincerely hope this guide has helped you grasp their fundamental concepts and empowered you to leverage their full potential in your C# projects. Keep coding, keep exploring, and continue building amazing things.